Hello all. In today's session of metrology and instrumentation, we will be dealing with transducers. A transducer is a device that converts one form of energy into another form. In measurements, it converts the measurand into a proportional electrical signal. In measurement applications, usually measurands may be pressure, temperature, linear displacement, vibration, etc. So all those signals will be converted into electrical signal. That's the main function of transducers. The working principle of transducers can be explained by this block diagram. The transducers contains two parts that are closely related to each other. One is this sensing element and second one is transduction element. The sensing element is called the sensor. This device will produce a response to change in the physical condition or physical parameter that is measured. And the transduction element convert the sensor's output to corresponding electrical form. The characteristics of transducers are given in this slide. First one is ruggedness, then linearity, repeatability, accuracy, high stability and reliability. Next is speed of response, then sensitivity, then small size. All these characters we have covered while in the previous session where we have discussed static and dynamic characteristics. Different types of transducers are available, and according to the area of application we select the correct transducer, and these are the various selection factors that are considered for selecting the correct transducer. First one is operating principle. There are different types of transducers based on operating principle like resistive, inductive, capacitive, optoelectronic, piezoelectric and different other types of transducers. So we will select the transducer according to the application based on the operating principle. Another factor taken into consideration for transducer selection is sensitivity. Usually we select a very sensitive transducer which is enough to produce a detectable output. Then third factor is operating range. So usually we select a transducer which maintains the correct range requirement and have a good resolution over the entire range. And fourth factor is accuracy. Usually we prefer high accuracy for getting good results. Another factor that is that have to be taken into account while selection is the cross sensitivity. And the sixth factor is errors. Usually we select transducers that are having minimum error. Another factor is transient and frequency response. Normally we select a transducer that meet the desired time domain specification like peak overshoot, rise time, setting time and small dynamic error. Another factor is loading effects. Usually a transducer should have high input impedance and low output impedance to reduce the loading effect. So we usually select such transducers. Another factor is environmental compatibility. Normally we select a transducer that can work under specified environmental conditions and maintains its input-output relationship and does not break down. Another factor is insensitivity to unwanted signal. Usually we select a transducer that is minimally sensitive to unwanted signals and highly sensitive to desired signal. So these are some of the factors that are taken into account while selecting the transducer for a certain application. Now the different types of transducers will be discussed in the next session. So that's all in this section. Thank you.